All right, my Math 2 friends, we've got lesson 4.2.2, selecting a trig tool. All right, so this is just kind of bringing everything back together. We have learned tangent in the last unit. We've learned sine and cosine in the last section. So this is just how to approach problems when you're given them and how to decide which tool that you're going to be using to solve it. So first problem says use the resource page, and I've got the resource page. It's right here. So here's my resource page. Choosing a tool. We know that cosine is adjacent over hypotenuse, sine is opposite over hypotenuse, and tangent is opposite over adjacent. Okay, so we've got all those. Sometimes it's hard to remember which one's which. So pretty much every math teacher ever has used SOH CAH TOA. SOH CAH TOA. And this is just a mnemonic device to help you remember that the sine is the opposite over the hypotenuse. That's the SOH. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. SOH CAH TOA. All right, so if you remember SOH CAH TOA, you can remember what sine, cosine, and tangent all mean. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. All right, so we go to our problem, and then we identify which tool we're going to use. So in this one, my angle of reference is 28. Here's my opposite. Here's my hypotenuse. SOH CAH TOA. I've got opposite hypotenuse. That's SOH, opposite hypotenuse. Up there. So, opposite hypotenuse. I must be using sine for this one. So we're going to use sine of 28 equals x over 19. We multiply both sides by 19, and x is equal to 19 times the sine of 28. Next one, SOH CAH TOA. So this is opposite and adjacent. So which one uses opposite and adjacent? Opposite, adjacent, tangent does. SOH CAH TOA. So we're going to do the tangent of 45 is equal to 8 over x. The x is in the denominator, so we exchange the extremes. X is equal to 8 over the tangent of 45. Next one, angle of reference. This is the adjacent leg. This is the hypotenuse. SOH CAH TOA. So adjacent hypotenuse, this is cosine. So cosine of 61 is going to be equal to the adjacent over the hypotenuse, so 18 over x. We exchange the extremes, and we get x equals 18 divided by cosine 61. D. On this one, our angle of reference is 25. This is opposite. This is hypotenuse. SOH CAH TOA. Opposite and hypotenuse. Look back up to where it said SOH CAH TOA. That's SOH, opposite hypotenuse. So sine 25, 6 over x, opposite over hypotenuse. So exchange the extremes, we get x is equal to 6 over sine 25. Sweet. All right, next one. This one we've got adjacent and hypotenuse. SOH CAH TOA. CAH. So this is CAH, adjacent hypotenuse. So cosine. So cosine of 60 is equal to 8 over x. SOH CAH TOA. So we switch those. Are you getting tired of me saying that? Hopefully you'll remember it now. I'm getting back at you guys for annoying me all the time. Now I'm going to annoy you. That's how it works. So here we got 30 degrees. This is opposite. This is hypotenuse. So CAH TOA. So we've got opposite and hypotenuse. That's opposite hypotenuse, so sine. So sine of 30 degrees is x over 42. Since x is in the numerator, I multiply both sides by 42, and x would be 42 times the sine of 30. Next one, 0 degrees. That's dumb. You can't have a 0-degree angle. This isn't even a triangle. I mean, if we wanted to, we could do opposite over, we could use tangent on this one. But come on, 0 degrees? Really? Anyways, all right, so this one, we've got 73 degrees. This is the adjacent. Mine just blanked. And this is hypotenuse. So this is CAH. So CAH TOA. So CAH is adjacent to hypotenuse. That's cosine. So cosine of the angle of reference is equal to x over 3. So we multiply both sides by 3, and x would be 3 times the cosine of 73. Last one on this page. So our angle of reference is 42. This is the opposite. This is the adjacent. So CAH TOA. So this is TOA because opposite, adjacent. So this is tangent, TOA. So tangent of 42 is equal to x over 12. Multiply both sides by 12, and we get x is equal to 12 times the tangent of 42. Sweet, we have done the back page. You can use your calculators to figure out what these are, like rounded to the nearest tenth or whatever. I'm just not going to waste the time and move on. All right, back to the front page. So we have done 4-68. We have completed that resource page on the back. Find the exact answer for x. Ooh, exact. What does it mean by exact? Well, when it means exact, exact means no rounding. So what would the exact answer be for this one? Well, let's work it out. This is opposite. This is the hypotenuse. So opposite hypotenuse, so CAH TOA. So this is opposite hypotenuse. So sine 25 degrees equals 29 over x. We exchange the extremes, and x is equal to 29 over sine of 25. That is the exact answer. Okay, if you plug it into your calculator, you're going to have to round the answer. So when it asks for a rounded, an exact answer, this is what it means as your exact answer. And it's actually kind of useful because sometimes, in more advanced problems, you'll have to use this to find something else. And I don't know if you've noticed it, but if you round in the middle of your problem and then round at the end of your problem, you get farther and farther away from the answer. So sometimes it's useful to use the exact answer in another equation and then round at the end of that one. Okay, so that's the exact answer. The approximate answer is when we round like to the nearest tenth. So the approximate, that's when we, little squigglies, means approximate. The approximate answer is when we actually use the calculator. So know the difference. If it's asking you for the exact answer, you would just leave it as 29 over sine of 25. The approximate answer is when they tell you to round. So sine of 25, 68.619. Nearest tenth would be 68.6. I don't round up because that's a 1 right there. So 68.6. That is the approximate answer. That's about what it is. Solve for x using a different trig function. Ooh, tricky. How could I use a different trig function? Well, let me tell you. If I use a different trig function, I would need to use the other angle. Now remember, these two angles have to be complements to each other, meaning that they have to add up to 90 degrees. So this has to be 65 degrees. Okay, so what I could do on this one instead is use the 65-degree angle, but this one is no longer the opposite. It's now the adjacent. And then this is still the hypotenuse. So what I could do instead on this problem, using this angle of reference, since now I have adjacent and hypotenuse, SOH CAH TOA. So this is CAH, adjacent and hypotenuse. So I could use the cosine instead. So the cosine of 65 degrees is equal to 29 over x. And then exchange the extremes. I'd get x is equal to 29 over the cosine of 65. And 29 divided by cosine 65, get the same answer, 68.6 again. So the sine of one angle is the cosine of the complement angle. So see here how we've got 29 divided by sine of 25. This is 29 divided by the sine of 65. They come out to the same answer of 68.6. So the sine of this angle is the cosine of this angle. They're the same. Sine of 25 is the same as the cosine of 65. So the sine and cosine, when you look at complementary angles, angles that add up to 90, the sine and cosine are equal to each other of those complementary angles. Okay, last one. So I can use opposite and hypotenuse. Opposite and hypotenuse is sine, so we can do sine of 53 is equal to y over 5, opposite over hypotenuse. So y would be 5 times the sine of 53. The other way to solve it is to use the complement. So what is the complementary angle to this one? That would be, what, 37? Do those add up to 90? Yeah, they add up to 90. So the other way to solve this one is to use the cosine of 37, because now I have the adjacent and hypotenuse. So the cosine of 37 is equal to y over 5. That was a bad y. There you go. So we would get y is equal to 5 times the cosine of 37. So what is this telling me? It's telling me that the sine of 53 and the cosine of 37 are the exact same number. So the sine of one angle is the cosine of the other angle. So if I plug that in, 5 times the sine of 53, I get 3.99, so 4. And if I did 5 times the cosine of 37, oh, there I get the same answer, 3.99. So the sine of one angle is the cosine of the other angle. The end. All right, math hard. See you guys later. Bye-bye.